All right, today we're going to talk about the definition of a parabola and some properties that we may not have known about parabolas. We've talked about them as the shape of a quadratic function. There's a more general definition. It's all the points equidistant. Equidistant means, you can learn that in geometry. Equidistant, you don't have this to write anything on, just listen right now. Equidistant from a point called the focus, which is inside the parabola. If it's opening up, it's here. If it's opening down, then it would be inside the same place, upside down. And a line called the directrix, that's down here. Okay, so what that's going to imply is that this distance is equal to this distance, which is what I'm going to show you on this picture. Now, this is on your paper, correct? All right. I need to move this down a little bit. Not like you guys need to see this on my video. Oh, well. Equations of parabola. Parabolas can be defined as a set of all points in a plane that are the same distance from the point called the focus and a line called the directrix. What you maybe would mark in your diagram is, you see this segment from P to a point on the parabola, and the segment that goes from that same point down here to the thing called the directrix. This P point right here is the focus, and this segment would be equal to this segment. Okay, and I'm going to mark it up more on that other picture that you have to the right. The directrix, again, is just a line that's not part of the graph, and the focus is not part of the parabola either. But you know how a circle is equidistant from the center point? And the center point of a circle is not part of the circle. The circle is all the points on the outside. But your points are all the radius distance away from the center of a circle. And that's similar to this in the sense that the distance that all the points on a parabola are is the same from the focus to a point on the parabola and from that same point to the directrix. So on this diagram, which you have, what we would be saying is, say, this segment, that length is equal to that length, this length is equal to this length, and this length is equal to that length. And likewise, right here in the middle, from the focus to the vertex is equal to the distance from the focus to from the vertex to the directrix. And the directrix is the line here. There's a lot of parabolic shapes in nature. Can anybody think of something at their house that would be a 3D parabola? You might have one at your home. 3D parabola. So it's like, and they're very, very shallow parabolas. Okay, a bowl. Some bowls have parabolic shapes. They do have parabola cuts in them. Okay, what I was thinking of is something that helps you watch. No. Okay, this is on your house. Some of you have them outside. A dish. Yes, it is a satellite dish. All right. You know your satellite dishes are parabolically shaped. I drew a really awful one right there. But there's that thing in the middle. All of the stuff bounces off the edges of your parabolic dish and bounce into that where it sends it to your signal to your TV. Very important shape. All right, but okay, I'm not going to go through all of this extra stuff. I think we just get to the business. I didn't include this diagram, and no, I'm not going to have you remember that this is called the lattice rectum. Didn't even sound that great, so you maybe will study it further in the future in calculus or something. I don't know why it's called that, but all right, just for funny. Moving on, you will be allowed to have a little sheet that says this for this unit. Not that you shouldn't already know it or need it, but we're going to go straight to a basic parabola. Let's talk about this one and find out what the focus and directrix is. So I'll talk to you right now about the formulas. Oh, by the way, I forgot. There's a little space underneath, I believe, here in your picture. Don't you have some room right here? Quite a bit. Let's write down a few things that we've talked about. The vertex form for a parabola was y equals x minus h quantity squared. Oh, and what's in front? A times the quantity x minus h squared plus k. You want to get that memorized. Then the standard form was y equals ax squared plus bx plus c. So this one, the first one was vertex form. The second one is called standard form. The vertex, if it's in vertex form, is hk. If it's standard form, you find it by doing x equals the opposite of b over 2 times a, and then you plug that in to get y. Okay, now, if a was positive, then it opened up, and if a was negative, then the parabola opened down. Now the new thing is the focus. The focus simply is the vertex point with a little addition to the k value. It is h, comma, k plus 1 over 4 times a. The directrix is a line. The directrix is a line, so it has to be written in an equation form. It's y equals, now remember your axis of symmetry is a vertical line. That is x equals the h value. The directrix is a horizontal line, so it's y equals, and it's k minus 1 over 4 times a. So that's because the k, generally, if it opened up, the directrix is a line below the vertex, so you're taking away 1 over 4k to find it. And the focus is above the vertex generally. That's why you're adding on to the k, the y value, to get the location of the focus. And its formula is 1 over 4a. So if we're going to try to do this for the basic parent graph, remember this is your parent. Okay, and it has a vertex of 0, 0. I'm going to talk to you again about the 1 squared, 2 squared method of graphing. So I'm going to do that way for all of the parabolas. Okay, so there's an a value here of 1. So you just say 1 squared is 1. So if you went over 1, you go up 1. Up 1, left 1 would be the other point. Then you say to yourself, well, 2 squared. 2 squared is 4. So you go up from the vertex 1, 2, 3, 4, and over 2. You do the same thing on the left, up 4, left 2. My it's stuck. Okay, here we go. There it is. You could do it again. If you did 3 squared, that would be 9 from the vertex. Oops, it's a little too high, isn't it? I'm only up to 8 here. So I'll go ahead and sketch what I have. You should graph your parabolas with 5 points, but you can have 3 points minimum. But 5 accurate points are best. Okay, so I've got a good picture of my problem. Now I'm going to find the focus. Oh, first you want to identify the a value. In this case, it's 1. It's the coefficient of the term, the x squared term. The focus takes your vertex, which was 0, 0, and it only changes the k part. So the h part is 0. The k part, you take 0 plus 1 over 4a. Now, what is a? Well, it's 1. So it'd be 0 plus 1 over 4 times 1. Well, that's 0 plus a fourth, so it's just 0, 1 fourth for your focus. Now let's go back up here. Because each time I think I'm going to find out what is 1 over 4 times a. 1 over 4 times a for this one was 1 over 4 times 1, which was 1 fourth. Okay, so now let's do the directrix. The directrix is an equation of a line. It's y equals k minus 1 over 4a, so that's going to be 0 minus a fourth, so it's just negative 1 fourth. It is a horizontal line at negative 1 fourth. Now you see how little these numbers are? These parabolas are pretty narrow. And a 1 fourth is pretty tough to graph since I've already kind of made a fat point for my vertex. So it's really, the focus is somewhere like right about there. And the directrix is a line that I can hardly even graph. So I'm really not going to have you graphing them much at all. We just want to kind of think about where they are. Okay, so that, it's a dashed line, and you just got to know how to find the equation for it. All right, let's try another. Number 3 has an a value of 2. So, oh my gosh, that 1 over 4a is going to be even smaller. Because 1 over 4a for this one's going to be 1 over 4 times 2, which is 1/8. Okay, now this parabola, now that I know what 1 over 4a is, the parabola has a vertex at 0, 0. Let's go ahead and graph this guy. 0, 0. Now, I'm going to do the 1 squared, 2 squared, but I have an a of 2. So to do the 1 squared, 2 squared, I have to do 2 times 1 squared, which would be 2. So I go up to right 1 and up to left 1 to get the first points after the vertex. Now I'm going to have to do 2 times 2 squared to figure out where the next points would be. And 2 times 2 squared would be 8. So from the vertex, we can go up 8 and over 2, because we did 2 squared. Up 8 and left 2. Oh, didn't hit. There we go. Mine's a little shaky. Good enough. All right, now we're going to do the focus and the directrix. We've got our 1 over 4a calculated to be 1/8. The focus would be at the point 0, and then I take my k value, and I do 0 plus 1/8, which of course is 1/8. For the directrix, I will say it's a line y equals 0 minus 1/8, which would be negative 1/8. Now you see what I mean by this one's going to be even harder to even show. You couldn't really even hardly put it on here because it's so close to there. You know? All right. You don't really have to put it on there. As long as you can write me the focus and the directrix. Okay, now things are changing up. This time a is a third. This is on the next page. I want to sketch the graph. Let's maybe go ahead and do that. But 1/3 of 1 squared. That's kind of going to be icky. The vertex here is 0, 0. But 1/3 of 1 squared would actually put me at, my vertex is 0, 0. 1/3. Well, I mean, it's not that you can't actually plot those points, but I'd rather you didn't use them as your accuracy points, you know. They're kind of awkward to plot. So would 2 be good to square? Because you got to do 1/3 of it. You got to multiply by that a value. So I'm going to do 1/3 of 3 squared. Okay, that's 1/3 of 9, which would be 3. So if I go 1, 2, 3 up and right 1, 2, 3, I will have points. And up 3, left 1, 2, 3. Because this parabola should be getting wider, and it is. We could probably put in some other numbers. 6 would work. 1/3 of 6 squared, though, is kind of big. Wouldn't that be 12? Off the graph. Let's just sketch it. Okay, so I've got some nice accurate points. I only had 3 this time because 5 didn't fit, but I did kind of estimate where those 2 were. All right, so I got the graph sketch. Now I'm going to find the focus and the directrix. Well, I need to find out what 1 over 4a is to do that. So 1 over 4 times a is going to be 1 over 4 times 1/3. Well, 4 times 1/3 is 4/3. But I can't leave a fraction in a denominator. How do you get rid of 1 divided by 4/3 and change it? It would be 1 times. When you divide fractions, you change to multiply by the reciprocal. You should know that, right? All right, so 1 times 3/4 is 3/4. That means our 1 over 4a is 3/4. All right, so since our 1 over 4a is 3/4, our focus is going to be at 0, 0 plus 3/4, so 3/4. 0, 3/4. Our directrix will be at y equals 0 minus 1 over 4a, so 0 minus 3/4 would be negative 3/4. And we're done. It can't be that easy because the vertexes have to move, right? H and K are not always going to be 0. Actually, I could maybe graph this one, at least show where these things are. 0, 3/4, at least I could plot it right there. There's your full focus. And then your directrix line would be down here. So fractions that flatten the parabola out, then you can start to see the focus and directrix because they move further away from the vertex. All right, number 5. Whoopsie, here we go. The vertex has moved. It is no longer at 0, 0. This one's at -1, -1. H is -1, K is -1. Our 1/4 times A, you look at the parabola here, A is 1. So 1/4A is 1/4. 4 times 1 is 4. All right, let's get the parabola graph. We'll go to -1, -1. We know it opens up, so let's go for the 1 squared, 2 squared method. The A value is 1, so we can go 1 squared is 1, up 1, right 1, up 1, left 1. Go back to your vertex. 2 squared is 4, up 1, 2, 3, 4, right 2, up 4, left 2. I think we can do 3 on this one. 3 squared is 9, so we can go from the vertex up 1, 2, 3, 4, 5, 6, 7, 8, 9, and right 1, 2, 3. And go back to the center line, which is your axis of symmetry. 1, 2, 3 to the left. Now we got a really nice parabola. If we can draw it. Okay. We've already decided that 1/4A is 1/4. So now we're going to write the focus and the directrix. Okay, directrix will be y equals something. Focus will have -1 for the H value. We got to figure out the K part, the next part. It's not K. It takes K and adds 1/4. So the K is -1, so we have to do -1 plus 1/4. Now you can type this on your calculator. You can exactly type -1 plus 1 divided by 4. You can hit your math enter button and it will give you a fraction. But I'm going to show how to do it without a calculator. 1, if you wanted to write as fourths, would be 4/4. 4 divided by 4 is 1. So -4/4 plus 1/4 would equal -3/4. But your calculator is going to give you that answer if you choose to use it. Bless you. Now, the directrix takes the K value, which was -1. It takes K and subtracts 1/4A. So K is -1. 4A is 1/4. 1/4A is 1/4. So I got -1 minus 1/4. So you can write -1 and 1/4. Or you could say y equals -5/4. Your calculator is going to give you -5/4. I don't care if you do a mixed number. If you understand how to just put those together, then write it like that. That's fine with me. So I'll take either one. Okay, let's try another. 6. All right, 6 has a vertex at 0, -1. The A value is -1, which tells me my parabola is going to open down, which we already have discussed. All right, let's go ahead and graph this thing. 0, -1. I'll do the 1 squared, 2 squared, but I need to go instead of up, I'll go down. Okay? You multiply whatever we get by -1. 1 squared is 1, so it would be -1. So down 1, right 1, down 1, left 1. 2 squared is 4, but -1 times 4 would be -4. So we go from the vertex down 1, 2, 3, 4, right 2, and down 4, left 2. And that's good enough. I can't fit anything else on here because 3 squared is a little too big. -9 would be a little big. Okay, now I'm going to do my focus. I'll need to know what 1/4A is. That's going to be 1/4 times -1, which gives me -1/4. So the focus is going to be at 0, and then I got to do -1 plus -1/4, which is going to be, that's what k plus 1 over 4a is for this problem. That's -1 1/4. If you want to write it as 0, -5/4, you can. So it's or, one answer or the other. And then Directrix, I got to take -1, the k value, and subtract the -1/4, which gives me -1 plus 1/4, and we already figured out what that is too. Y equals -3/4. Questions at this point? No? I know some of you are going, oh my gosh, there's a lot of fractions. Yep, there are. You got to remember that it's 1 over 4 times a. That's where I see the mistakes is people will think it's 1/4 times a. That's not the same thing. All right, so that's where I find the only reason people mess this up at all is they start thinking that k plus 1 over 4a means 1/4 times a when it does not. You put the whole a value down here no matter what it is, fraction or not, okay? All right, a here, -1/2. Let's try this right now, do the 1 over 4a part. Okay, so 1 over 4 times a is going to be 1 over 4 times -1/2. Okay, so figure out, and if you need to use a calculator, I don't care, but you should be able to multiply 4 times -1/2 in your head. All that means is half of 4 and sign change. So this should be 1 over -2, which is the same as -1/2. All right, so right now we got it. We got the 1 over 4a is -1/2. Let's check the vertex. Vertex for this parabola is -2, 4. The format says -8 plus k. I know it opens down and it's going to be a little wider than the normal parent graph because the 1/2 a value, -1/2. So I'm going to go to -2, 4. The 1 squared, 2 squared method might be a little awkward with this. I wouldn't want to do 1 squared because it's going to be a fraction, right? So maybe I'll do -1/2 times 2 squared. It's easier than plugging points in, I'll tell you that right now. This method is easier than plugging in points. 2 squared is 4. Half of 4 is 2, so it'd be -2. So if you want to go over 2, you're going to be going down 2, right 2. Or down 2, left 2. How about, what else do you think would be nice to pop in there? Or to do the 1 squared, 2 squared method with? 4. Okay, -1/2 times 4 squared. Okay, that's going to be half of 16, so -8. So if we wanted to go to the right 4 from the vertex, we'd have to go down from the vertex 8. 1, 2. I'm going to go down first. 1, 2, 3, 4, 5, 6, 7, 8. Right 4. 1, 2, 3, 4. I got to go back to the vertex, down 8. Just make sure you're going straight down. Stay on your axis of symmetry. Go left 1, 2, 3, 4. Oh, this is going to be nice. Now we know very good shape of this thing. We've got 5 points. All right, now let's do the icky part. Focus. The vertex part of the formula helps you. Well, you have to know the vertex. The focus will be starting out with the same h value, -2, but we got to take 4 and add that 1 over 4a, which was -1/2. Just use your head. What's 4 take away a half? 3 1/2. So you can write 3 1/2. If you choose to use the calculator and you type 4 minus or plus -1 divided by 2, it's going to give you a mixed number of 7/2. So if you write 7/2 instead, that's totally fine. and the directrix y equals. Now I got to take the k value of 4, and I got to subtract 1 over 4a, which was negative 1/2, which means I'll end up adding. So it's going to be 4.5, or you can write it as 9/2. Okay, let's try again. Well, this is different. Now they're giving us something, like the focus or the directrix, and we're going to go backwards. So they're telling us the vertex. So if the vertex is at the origin, then it's at 0, 0, which makes h0 and k0. They gave us the focus as negative 1/4. Well, the focus comes from this part of it, k plus 1 over 4 times a. With me? K plus 1 over 4a turns out that it equals negative 1/4. Well, I need to know what's k. Do I know k? Yes, from the vertex. It's 0. So I got 0 plus 1 over 4a equals negative 1/4. Some of you may already know what a is. Well, I don't need that 0 there, right? So let's solve this. 1 over 4 times a equals negative 1/4. So here's how we're going to do it. Cross products are equal. So if I want to solve for a, 4a times negative 1, negative 4 times a equals 4. No matter what I do, divide by negative 4, you get negative 1. Now that we know the origin is the vertex and the a value is negative 1, the parabola's equation would be y equals negative x squared. All right, maybe we should write down our format up here for the equation of a parabola in vertex form. All right, this one's vertex at the origin also. Your h and your k are 0, and now it gives you the directrix. The directrix formula is k minus 1 over 4a. Well, they just told me that y is negative 1/12, so I'm going to replace y with negative 1/12. That'll equal my k, which is 0, minus 1 over 4 times a. Does anybody know what a is already? You can kind of look here and here. How are you going to get negative 1/12 to be negative 1 over 4a? Put in a positive 3. Yeah. All right, if you already see that, that's cool. I'm going to show it algebraically. Negative 1/12 equals negative 1 over 4a. Cross products are equal. So that'd be negative 4 times a equals negative 12. Divide both sides by negative 4. A is 3. So this equation's just y equals 3x squared. It's just a little tedious. I'm showing a lot of steps that maybe you didn't have to have me show, because if you know this is 0, you don't have to fill it in, but I just wanted to show you how you can make substitutions like you did in geometry for all stuff. Okay, origin, is not the vertex this time. Now my h and k are 10 and negative 4. The only one I care about is the k. I got to focus with this value of the value in this position, negative 15/4, which comes from taking k, which is negative 4, and adding on 1 over 4 times a. All right, do we understand? Tell me if you don't know how I just wrote this equation. In the focus, so we know that the part right here is this. It comes from doing k plus 1 over 4 times a. And I just filled in k, and then I don't know what this is yet. That's what I'm going to figure out. So this time, we have to add 4 first. Okay, so if I'm going to add negative 15 fourths plus 4, you can use your calculator. It'll take care of it. But that's just 1/4. Because 16 over 4 is 4. And then I'd have 1/4 when I add, or subtract, however you want to look at it. That gets rid of this. I've got 1 over 4a, so check it out. A is just what? Yep. Yeah, it's just 1. 4a equals 4, so a is 1. We did all that work to find out it was only 1. All right, ready to write the equation? Remember the format, and I guess you already have it. It's written down probably somewhere close by, but this is it. So I'm going to put y equals, our a value was just a 1. You don't even need to write it there. You can put just a parenthesis. X minus 10 quantity squared minus 4. Okay, remember that the directrix is found by doing k minus 1 over 4 times a. K is negative 1 in this problem, so I'm just going to replace the y, the k with the negative 1 and the y with negative 7/8. So negative 7/8 is equal to k, negative 1, minus 1 over 4 times a. We will need to add 1 to both sides. When you add 1, negative 7/8 plus 1 is 1 can be written as 8 over 8. So that would be just 1/8 equals negative 1 over 4a. Don't forget the minus sign in front of the 1 over 4a. Then if I cross multiply, I'll have 4a equals negative 8. So this time a is negative 2. So my equation for number 11, y equals negative 2 times x minus 7 quantity squared minus 1. Right, that puts you at worksheet 7. Wait, this is 7 or 8? That's 7a? Okay, guess what this is? It's pretty much the same thing over again. So let me just show you. This is I told you I'm going to give you this little chart. I'll give you guys one of these tomorrow. You really don't need it because you've got this written down on your paper, right? You can refer to it. If you want, yeah, I'll just give you one tomorrow because I got to make sure I have enough. Right now, this is just some general stuff. But you're going to, this is just an example of stuff I just went over. Okay, so I've already given you examples of everything. These are just more examples. So I would like you to start working on these, trying to answer the questions. I can go over more of them tomorrow. But you are essentially assigned through worksheet 9, which is all on focus and Directrix. I'm not expecting you to do all that tonight. That's not what I'm implying. We're just going to be working on it for the next day or two, right? So that's the end of the lesson for now. Over and out. If I know how to turn this thing off.